Hello all. Today we will start the module 5, fifth module, that is kinematics. Okay, first we will see the introduction before going to the problems. So first we will see how the classification goes on in the mechanics. Mechanics is a branch of physics which deals with the cause and effects of motion of a particle, okay, rigid objects and deformable body, etc. Mechanics is classified into two streams, that is kinematics and dynamics. So this module 5 is mainly on the kinematics. We are concentrating on the module 5, that is kinematics. The word kinematics means the science of motion, that is a branch which deals with the study of motion without going to the cause of the motion, that is force, torque, etc. Okay, and it's a Greek word, that is kinema. Kinema means a motion. So this is a definition of kinematics. So we will briefly go through the detailed study about the kinematics now. Okay, first one, force. That is, force means already we have studied about the force and we are doing problems in the beginning, that is from the first module throughout we are like dealing with the forces itself. So already we know the introduction, still we will see once again the force. It is surrounded by the variety of moving objects in our day-to-day lives, that is cars, buses, aeroplanes, boats and animals, human beings. So many things are the example. That is the moving objects, whatever it is there. So it will be on the basis of the force itself, right? An object that is moving, it is said to be a motion. So if any object, if it is moving, so without the force, the motion will not develop. So that is the introduction for our force. Okay, here you can see the three examples. You can take it any examples here. Of few examples I have mentioned. What makes the ball move? That is, the man pushes the ball with the bat, right? So the man is giving he is applying the force. Then only the object, that is the ball, it will move. Next, the car. What makes the car move? The man pushes the car, like he is applying certain force, so that's why the object, that is car, is going to move. That is pushing. You can see the man is pushing the car, right? So there is a two types, it is pulling and pushing, so we have to concentrate on that also. The second example, it is he is pushing the car, right? And the third one, what makes the wagon move? The child pulls the wagon, like he is pulling the the object, right? He's pulling that. So pulling and pushing, the difference between we have to know. In the above picture, the objects are being moved by push or pull, right? So you can we have to classify which is pull and which is push. So there are two types of main motion it is there in the forces. A push or a pull acting on object, it's called force. And in the force, both are forces, right? Pushing also force and pulling also force. Both are forces. Okay. Here we will see a relative motion, that is a motion, normal example for a motion. If you are sitting in a chair reading this sentence, that you are moving, right? You are not moving relative to your desk or your school building, but you are moving relative to other planets in the solar system and the sun. We are in the rest, but still according to our relative other planets, will be in the motion. So that will be a relative motion which is relating to the planets, that is a solar system and the sun. Okay. Definition for a distance, that is distance moved. Okay, so it is the actual length of the path traveled by a body. So if you start anything and you're closing the things there, so that will be a distance. You can see in the picture the total distance covered in one lap is equal to 400 meter. For example, if any a person is doing a running in the ground, so he is starting from the point and ending to the same point, so that will be covering distance, complete distance. So this one we can see a definition of distance. Next one, displacement. It is the length of the shortest path traveled by a body from its initial position to its final position, right? So there is a difference between distance and the displacement. So just a body, it is a shortest distance just taking and keeping in a certain place, so that will be comes under the displacement. Okay, the conclusion is distance is length of all lines passed through by the object. It will be comes under scalar quantity, and in scalar quantity we all know it is a having magnitude. Okay, and the displacement it is a position change of an object from the initial point, right? It's just a change from initial point uh, to the another point. So it will be comes under the vector quantity, that is magnitude and also the direction both. Here we'll be knowing both magnitude and the direction. Okay, next one we will see the definition for a speed. That is speed of a body. It is a speed of the body is a distance traveled by the body in the unit time, that is distance divided by the time. So if a body travels a distance s in time t, then its speed v is, it will be v is equal to s by t, right? So the SI unit for a speed is meter per second, right? So since speed has only magnitude, so it will be comes under scalar quantity. Okay, here you can't see the direction, only the speed will be there, a magnitude. So that's why it is comes under a scalar quantity. Okay, here we can see the formula for the speed, that is distance by time. So here speed v is equal to delta x divided by t. Okay, suppose we will just an example. Suppose you ran for a 2 kilometer in 10 minutes. What is your the rate? What will be the rate? So here I am taking the distance as 2 kilometer divided by time as a 10 minutes. So it will be 0.2 kilometer per a minute. So here we are taking time as a minute, so that's why I'm mentioning a minute. Please remember the units for the problems. In the problems we have to while concentrating on the problems, units are important. So kilometer per minute, if they're taking in a seconds, kilometer per second will be there. So here kilometer per minute, because we are taking in the time as a minute. Okay, speed is over. Next, we will see after the speed the definition of a velocity. The rate of motion of a body is more meaningful if we specify its direction of motion along with speed. The quantity which specifies both the direction of motion and speed is a velocity, right? So the velocity of a body is the displacement of a body per unit time. So displacement by time taken. So displacement means as we know, it is like changing from one position to another position with the shortest distance. Since velocity has both magnitude and direction, it will comes under vector quantity. So here we'll be knowing both. We'll be knowing direction and we'll be knowing the magnitude. Both the force magnitude, both will be knowing. So that's why velocity comes under vector quantity. Here in this example, there is a escalator. So here you can see it is speed or a velocity, right? Escalators have the same speed, that is a constant speed, but have different velocities because they are going in different directions, right? So it will be in a different directions. Maybe it is going upwards or downwards. There will be a different directions will be there. As we all know, when we are going to a malls or a big building, so one side it will be going upwards and one side it will be coming downwards. So definitely the speed constant will be there, but the velocity it will be different. Next, here also one more example. If a car is going around the racetrack, its speed may be the constant, but the velocity will be changing because it is changing direction. So here the car race, every time it will be not in the same the linear motion, I mean the straight motion. It will be in any different directions. So that time velocity it's changing. So speed will be the racetrack may be the constant or the same maybe, but velocity will be changing because it's changing directions. Thank you.